All right, so the line is passing through 5, -5. And 1/3 x. So talking about a line that's passing through 5, -5, and it's perpendicular to y equal to 1/3 x plus 3. So we need to get the slope. The slope of this line is 1/3, but the slope that's perpendicular to this line would be -3/1, which is just -3. So you're talking about perpendicular line, you're flipping that fraction and you're using the opposite sign. All right, and so now we can use point slope form, y minus y1 equal to m times x minus x1, where this is going to be our x1, y1. Plug it in accordingly. So y minus -5 equal to -3 times x minus 5. Y plus 5. Distribute the -3. That's -3x plus 15. Finish it off by subtracting 5 from both sides. Y is equal to -3x plus 10.
That's all?
Yep, that's it.
Thank you.
Not a problem, not a problem. Anything else before we go anywhere else? So don't forget, we're done with chapter 2. Let me see, last class. Yeah, so we're done with chapter 2, so we're moving into 3.1 today. So before we do 3.1, questions on anything? That'd be good. All right. All right, so 3.1 starts off with quadratic functions. Where in the graph of your quadratic function will be a parabola. Let's do it like this. All right, your parabola could be concave up or concave down. Whether it's your smallest value or your largest value, that would be your vertex. So let me see this. That's concave up. This is considered concave down. And this vertex is a maximum. This vertex is a minimum. And the coordinates of your vertex is always going to be considered HK. All right, so your standard, I should put standard form, left out form. So standard form of a quadratic equation, f of x is equal to a times x minus h squared plus k. And of course, a cannot be equal to 0. All right, so if a is greater than 0, and that means positive, in other words, if a is positive, then your parabola opens up, or it's concave up. If a is negative, or in other words, a is less than 0, then the parabola opens down. All right, problem before I scroll up. Well, they separated those, so let me do this. I'll separate it as well. All right, so graphing quadratic functions with equations in standard form. So we want to determine concavity, whether it's concave up, concave down, opens up, open down. Determine your vertex, the coordinates of your vertex. Find x-intercepts, if any. Find your y-intercepts. Then you want to plot the points from 2 through 4 and additional points if necessary. All right. All right, so they asked us to graph f of x is equal to -2 times the quantity of x minus 3 squared plus 8. So going off of step 1, first thing they ask us to do is to find or determine whether it's going to open up or open down. Here, before I go into step 1, I'm just going to rewrite standard form. All right, so that's our standard form. So a is equal to -2. So because a is negative, that means it opens down. All right. Vertex, notice there is a minus sign in the formula and a minus sign here. So I'm just going to take the value that they gave us for h, that would be 3. And then this is plus and this is plus. So I'll just take that value, which is 8. If those signs were different, then you would take the opposite sign, of course. Or for h, you would take the opposite sign. For k, you would take the sign that they give you. So in other words, if I had x plus 3 minus 8, I would take the opposite sign here because in order for it to be a positive, that means I had to have plugged in -3. And then the sign that they have there for -8 would just be the -8 because plugging in -8 for that positive would just turn it negative. So once again, for h, you would take the opposite sign. For k, you would just take the sign that they give you. So,
Right, so
yes.
like forever we'll do that?
Well, for these type of situations, when you're talking about using the standard form to find your vertex? Yes.
Yes, sir. Like, we'll switch the negative h to a positive
right.
every time.
Yes.
Okay, cool. Sorry. Thank you.
All right. So for your x-intercepts, remember characteristic of all x-intercepts is that y is equal to 0. Don't forget, if your function is in, if your equation is in function notation, then you substitute it in y for f of x. So that means f of x is equal to 0. So in order to solve for your x-intercepts, you will set f of x equal to 0. And solve accordingly. Subtract 8 from both sides. Divide by -2. So we have 4 equal to negative x minus 3 squared, excuse me, x minus 3 squared. Take the square root of both sides. And of course, that square and square root will cancel. That'll be x minus 3. And I'll probably just take it down further. So that's plus or minus square root of 4 equal to x minus 3. So that's plus or minus 2 equal to x minus 3. Then add 3 to both sides. X is equal to 3 plus or minus 2. Three plus 2 is 5. 3 minus 2 is 1. So my order pair here is going to be 5, 0. Order pair here, 1, 0 for my x-intercepts. Don't forget y was equal to 0. All right, questions before we look at 4. We're gonna find the y-intercept. So for your y-intercept, that means x is equal to 0. Oh, that's a minus 3. So let me check, so I'll make sure. Yeah, plus 8. All right, so plug in 0 for x. right, so plugging in 0 for x, give you your y-intercept. All right, questions. All right, so that's 4, right? So let's try graphing these points and see what we have. All right, so we know it's going to open down for us. Our vertex is 3, 8, excuse me. So go to the right 3 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. That's my vertex. 3, 8. Then I have a y-intercept at 1. So it's 1, 0. Then at 5, 1, 2, 3, 4, 5, 0. Then I have a y-intercept at 0, -10, which is down here. Missed a few points, but yeah. So it should look something like that. And of course, if you were to plug in some more values, you can get it more accurate, get more points on the, oh, that's worse. I'll try one more time. Yeah, okay, well, we'll leave it like that. Anyway, that's what your parabola should resemble, something of that nature. Questions. All right, let's see. All right, so If you want to find the vertex of a parabola whose equation is f of x, or in the form of f of x equal to ax squared plus bx plus c. In other words, it's not in that standard form that we referenced earlier. Then we can use or find our x coordinate or x component of our coordinate to be negative b over 2a. And then if we plug in that negative b over 2a into the equation, we will get our y components. So let's try to do what we just did with this one. All right, so it still opens down in this case. So if A was positive, of course it will open up, but this one opens down. Two, we can find our vertex by recognizing we got -1 for A. B is -2. So negative B over 2A. It's going to be -2 over 2 times -1. Which would be +1, and I probably should have called this H. Since it's R, let me make more room over here. Let's see, plug in negative. Oh, I left the negative off because I plug in -2 and I plug in -1, but there's this negative right here. So make sure you're careful with that. So let me write that neater. You have a -2 over 2 times -1. So actuality, that should be a +2 on top. So that should be a -1 as our H. All right. Questions on H before we find K. So to find K, we'll plug -1 into the equation. -1 squared is +1, but that negative is still sitting out front. And that's -2 times -1, which is +2. Is that a question? I guess not. All right. So -1 plus 2 plus 1 will just be
God.
2. All right. So your vertex -1, 2. So, of course, make sure you're careful with those negatives. All right, questions before we look at 3, X-Intercepts. So don't forget, To find your x-intercept, you gotta let y be equal to 0. So we're looking at, I think I want to use black. Negative x squared minus 2x plus 1 equal to 0. So unfortunately, that is not factorable. So we'll have to use the quadratic formula. All right, so plug them in. It's negative 2 plus or minus negative 2 squared minus 4 times negative 1 times positive 1, 2 times negative 1. So negative turns positive on the outside. On the inside, a negative 2 squared is 4. 4 times negative 1 times positive 1 is going to be a positive 4 all over 2. Should be a negative 2. All right. 2 plus or minus square root of 8 over negative 2. And since we're trying to graph this, we're going to need the actual decimal value for the points. All right. That's negative 2.4, 0, and 0.40 for our coordinates. All right. Now we need to find step 3, y-intercept. Oh, step 3 or 4. Oh, this is 4. And to find the y-intercept, we let x be equal to 0. All right, so that ordered pair is 0, 1. All right, so we can go ahead and graph now. We know it's going to open downward. That parabola, not parabola, vertex is negative 1, 2. Left 1 up 2. And negative 2.4 and positive 0.4. Then we have 0, 1. That's my y-intercept. That's good enough. That'll be our lines. Matter of fact, I need to make that purple. That'll be our parabola. Any questions? All right, let's see what else is in this section. Oh. All right, so if a is greater than 0, we already touched on that it will concave up or open upward. So that means that your function has a minimum at negative b over 2a. And if a is less than 0, in other words, a is negative, it open downward. So that means it has a maximum at that x equal to negative b over 2a. All right, questions on anything? See if I see at least one more example. There's something different. There are a couple word problems in the examples, but I don't think there are any in the homework. I'll check that out. I think word problems are for later. This one right here. All right, so consider this equation or this function, negative 3x squared plus 6x minus 13. So determine whether it has a minimum or maximum, and say it without graphing, but yep, so that's what we'll do. First of all, we recognize a is equal to negative 3. Since a is equal to negative 3, that means it opens down. And if it opens downward, that means it has a max, a high point. If it opens up, that means it has a low point, which is a minimum. Okay, find the minimum or maximum. So a is equal to negative 3, as we already stated. B is equal to 6. That means x is equal to negative b over 2a. So that's negative 6 over 2 times negative 3. That's negative 6 over negative 6, which is 1. For my x, or I guess I should have said h. I put an x, I should have said h. And then k is to plug in negative b over 2a into the function. We just found negative b over 2a to be positive 1. So we're plugging in positive 1, so it'll be negative 3 times 1 squared plus 6 times 1 minus 13. Was it minus 13, right? Yep. Negative 3 times 1 plus 6 minus 13. So that should be negative 10. So the coordinates of the vertex is 1, -10. And our vertex is our, we said it was a minimum, maximum. And it asks us one more thing. Identify the domain and range. All right, so when we look at our domain and range, we do want to look at, make sure we are looking at the right things. You know, your domain or your X values, and we're also talking about left to right. How far can I go left to right when it comes to my graph? Or what values can I plug in for X when it comes to my function? And then with the range, what values can I plug in for Y? Or would I get out for Y? And then also, how far up and down would I go or could I go according to my graph? So either way you look at it, you just have to make sure you're looking at it properly. So when it comes to my domain, left and right, it will continue to get wider and wider and wider to infinity. There's nothing stopping it from going all the way to 100, positive 100, or negative 1 million on the left. So your domain for your parabola will be negative infinity to positive infinity. All right. And now your range has a max at -10, but it doesn't go any higher than that. So after from -10 on down is your range. So you would come from negative infinity to -10. Your lowest value is always first. So negative infinity is lowest, the lowest you can go, because that never stops. And then it goes up to -10. And -10, you will use a bracket on it because it is a part of your range. And that would be it. So your range will be affected or determined by your vertex, whether it's a max or min. All right, questions? Questions, any questions? All right. Well, it was 1:31. We don't necessarily have to start a new section today. So make sure you guys are getting in there and knocking out this My Math Lab work. So we've done chapter 1 and chapter 2. Like I said, we're on chapter 3 now. So make sure you're knocking this stuff out. We halfway through. Next week will be midterm week. Of course, we're not doing a midterm. We're just going to go ahead and keep flowing since we hadn't talked about one up to this point. But make sure you are, knocking out this stuff and taking advantage of the opportunity. Any questions or concerns before we close out? All right. Well, have a great weekend. Be safe. And I will see you on Monday.